welcome back to my channel. You're welcome for another physics tutorial. It will be a time where we'll be resolving the electric field using Gauss Law. Welcome. This is where we'll be starting from. The question is to show that for a line charge of linear density, this is the symbol for linear density, and length this is the symbol for length. The electric field E at a distance r away from the line is this. So we want to show that the electric field formula is this using Gauss Law. So now the solution goes thus. First of all, we must be able to state what Gauss Law is all about. Gauss Law states that the electric flux around an enclosed body, inside an enclosed body, is directly proportional to the charge within that enclosed body. So now we look at it. We say Gauss Law states that the electric flux around an enclosed body is directly proportional to the charge in the enclosed body. So this is just a general way of stating the Gauss Law, but formula wise we can see. But before I write the formula, I must explain what electric flux is. Electric flux is electric field through a specific area. Electric flux is electric field through a specific area. So if I truly want to interpret this Gauss Law now, I can say, okay, let me give electric flux a symbol. Let me say this is electric flux. I said it's directly proportional to what? Charge within the enclosed portion. So I'm not going to write it as electric flux. I'm just using this formula to represent it. Will now be equals to Q over E naught. This E naught you are seeing here is electric constant. So we have removed the proportionality symbol. We're changing it to equal to why this is the electric constant. So now if we now properly write it, why we interpret electric flux as what? Electric field through a specific area, we can now write electric flux as EA. This time around, this is electric field, this is area. So EA equal to Q over E naught. That is where we are now. So we are ready here now. We'll go back to the question. This is where we are going to. So now this is the question. It says show that this. So now at this point, in order to get the answer we're looking for, we are assuming that the surface we are talking about now is a wire. So and a wire will be treated like a cylinder, definitely. A wire will be treated like what? A cylinder. So for a cylinder, EA equals to Q over what? E naught. So we can now write E as what? Q over E naught what? A, right? For charge density, we know that linear charge density, here they were already told that from the question that a line charge of linear density this. Now generally when you hear linear density, listen attentively at this point. Linear density formula is given as linear density, let me put this symbol in bracket, is the charge per unit what? Length. So we can easily write lambda equal to what? Q. Let's call this one equation 1 initially. Q over L. So now what will be Q from here? Q will now be what? Lambda L. Let's call this 2. Now if you put 2 inside 1, substitute 2 into 1. You have what? 1 will now become, this is 1 initially. If you now put the value for Q from 2, that 1 will now become lambda L over E naught A. Sorry, let me place my camera well. Okay, 1 becomes this. Now something is left. We are dealing with a cylinder, and the area of a cylinder in this case now we're going to use 2 pi r L. So if you put it in, let's call this 3, let's call this 4. If you put 4 for cylinder, say for cylinder, area is this. So if you substitute 4 into 3, you now have E will now be, sorry, let me place my camera, that's 3 will now be, that's this is 3 initially, to now become lambda L over E naught. Put area now as times 2 pi r L. This is times, please. So eventually we can now write it as E will now be equals to what we have initially, lambda L over 2 pi. We can now write it as 2 pi r E naught L. When we multiply everything here together, please, this is times, like multiplication sign. So when you multiply that together, you can write it like this. L will cancel L up, or L goes in L. So E can now be written as lambda over 2 pi r E naught. So we have been able to prove it. Quite easily done. Quite easily done. So we have been able to prove that the electric field is this from Gauss Law. That's what the question requested. It's the same thing. Definitely. So it's the same thing. It's just that you can write it. This can still be written as E naught R. Doesn't make any difference. So quite easily done. Now we can use it. This formula we've gotten, we can use it in a question. So let's take question 1 to typify this example. So here is the first question. We'll be using what we have gotten to typify. So let's solution. As I've always taught, when you see a physics question, calculation, now you take your parameters first. Calculate the electric field at a distance of this. Let's take down the distance. Now you know in this respect, we'll now be writing distance as T, rather we'll be writing it as R. So distance is 320 centimeter, which can be written as 3.2 meter. That's divided by 100, right? From an infinitely long wire carrying a charge of this. Now it says carrying a charge of this. Now charge normally is supposed to just take coulomb, but you are seeing coulomb per meter here. That means this particular something given is not just charge. This is charge per length. So this is linear what? Density. So that is, in physics, it's a secret. You work with the unit to know what you're dealing with. Assuming this was just coulomb, here is truly a charge. But this is now, this is the charge per unit length. That means this is the linear density. So you have these two parameters, and we're asked to calculate what? Electric field. Making reference back to our formula, we have electric field equals to lambda over 2 pi E naught R. Now we're giving E naught as a constant there already. 8.854 times 10 raised to power minus 12 coulomb square Newton meter square. Now put everything in. You have 8.3 over 2 pi times 8.854 times 10 raised to power minus 12 times 3.2. Once you put this in your calculator and you calculate properly, you have 4.66 times 10 raised to power 10 Newton per coulomb. So that settles the question. So this is another dynamic question. We'll be applying the Gauss law. Calculate the electric field at a surface of a sphere of radius this. So let's take down our parameters. We have a sphere and its radius is 10 centimeter. You can write that as 0.1 meter. Enclosing a charge. So now we have Q as 0. This time around is not charge per length, right? 0.5 this. So you'll be wondering, what formula are we going to use? Mind you, the formula we used directly, that is this very one, You know, we got this formula when we were calculating with respect to a cylinder, that is a wire. Now this surface here is not a cylinder, it's a sphere. So we are going to back off to a point when we are proving. We got to this point. Remember this point. At this point, we now put in this Q as a, it's part of physics manipulation. If you check my last class, I taught something on that, but using a question. As at this point now, because we are trying to prove this, we have to introduce Q in form of linear density. But it doesn't mean that this formula in itself is not alright. But because we are going somewhere to prove this, we have to introduce Q in its linear density form, and A as a cylinder. Now we are going to use this formula in this form to resolve that question. So you have EA equals to Q over E naught. This is still from Gauss Law. The electric flux directly proportional to what? The charge in that enclosed portion. So now you have we're looking for the electric field, right? E will now be what? Q over E naught what? A. So we have the charge already, 0.5 coulomb. E naught constant given times 10 raised to the power minus 12. Then since it is fair, the area will be 4 pi r square. So you have 0.55 over 8.854 times 10 raised to the power minus 12 times 4 pi times the r from our question, 0.1 square. So when you resolve all of this, you have your final answer of 4.94 times 10 raised to the power 11 Newton per coulomb. Thank you to you for watching that class. I would love you to drop your questions for me in the comment section. Do subscribe to my channel and share with your friends. Thank you.